All right. Oh, get this thing going. Okay. So now, as we can see, we have this equation to solve. Here, we have to solve this wonderful equation. Again, it's just, what do you call it? It's just section 1, we're just in chapter 1 again. I mean, normally we have an x here, and here we have a y, but that's okay. So we have -2 plus 3y is 7. Okay, so let's get y, let's isolate y. So we add 2 to each side. We get 3y is 9, as you can see. Dividing both sides by 3, we get y equals 3. That's what we get. Now, okay, we know what y is. Are we done with the problem? No, we're not quite there yet because we have to figure out what x is, right? Remember, we want to know what y is and we want to know what x is. Well, what do? Well, remember, it's over here, but also on this slide, we got x in terms of y. So we can use this. I mean, you could take the y and put it back into either equation to get x. It's the same idea. You'll get the same answer. But we have x equals something in terms of y. Well, let's just use this. So we have x equals -1 plus 3 times 3, right? Excuse me, -1 plus 3 times y, which is -1 plus 3 times 3. Right? We got y is 3. So we get -1 plus 9, which is 8. So our unique solution then is 8, 3. So we got y in terms of x. Again, we could have gotten x in terms of y. Excuse me, we could have, back here, we could have gotten y in terms of x. You know, I know someone asked about that. That's fine. You could have done that. If you do everything correctly, you'll get the same answer, 8, 3. And if we graphed it as a check, you know, if you graph this in Desmos, you would be able to see, this is what you would get. You would get 8, 3 as the point of intersection, which tells us, which confirms for us, this is the right answer. This is our way of checking, so to say, okay? Which is good. Okay, any questions on that? Okay, so I'm going to keep going then. Now we're in a new method. We're going to see a new method, excuse me, called the elimination method. You know, I wrote it out here. The whole point, as you'll see, is you want to somehow multiply an equation, or maybe both, by numbers in such a way so that the coefficients of a variable, x or y, can be eliminated once you add them. When I say opposite in sign here, I just mean one of them could be like 2, the other one could be -2. I mean, I will demonstrate through examples, don't worry, but you want to multiply by numbers so that when you add the equations together, you kill off a variable. I mean, that's really the whole point. Same thing with the substitution method, right? I mean, there are different ways of achieving it by killing off a variable. In substitution, we got one variable in terms of the other. Here, we're going to eliminate a variable by adding the equations, possibly multiplying one or both of the equations by something. So once you add and eliminate a variable, you'll get an equation in one variable. And then you solve that equation. To get the other variable, just like in substitution, you would, they call it back substitute. You basically take the number you get, plug it back into one of the original equations, And you get your solution, write it as an ordered pair. And I myself haven't done this in the lecture. Check your results. So I probably won't ask you to do that on an exam or something. You could also check really, I guess, in this class using Desmos, graphing in other words. Let's go. All right. I mean, this is the method. It's in the notes. So, you don't have to memorize the method. But let's dive right in. Okay. So we have this system. We're going to solve it by elimination using that method. So somehow we want to eliminate a variable when we add the equations together. Okay, well, here I look at the y's. I will get to the x. Well, yeah. So if we look at y's, right, here we have 3 times y. Okay, we have minus 4 times y here. Well, if you add those, you're not going to eliminate y, right? Same thing with x. You're not going to eliminate x. However, if I multiply the top equation by a 4, right, and the bottom equation by 3, the coefficient of y will change to 12. The coefficient of y here will change to minus 12, which is what I'm doing here. So what I'm doing is this, looking at these two, looking at the y's maybe first because of this minus sign. I see that, well, we have 3 here and negative 4. Well, you can't add those together and get 0. But if I multiply this by 4, the top equation, and multiply the bottom by 3, then we can add and eliminate. So that's what I'm doing here. So for the first equation, I'm going to multiply by 4. So we distribute. We get 8x plus 12y is 84. For the second equation, as I just said, I'm going to multiply by 3. We get 3x, right? That's 9x. Minus 12y is 69. Okay? Like so. And what does that do? Well, it gives us this new system, as you can see, a brand new system it gives us. Now, if we were to add these, as I'm doing here, right? These 12y's are going to vanish. The 8x and 9x you add, you get 17x. Here, 84 plus 69 is 153, as you can see. So 17x is 153, right? So by multiplying then adding, one of the variables is gone. And we're in the situation where we have an equation with only one variable to deal with. This is that equation. 17x equals 153. Wait. Oh, I got nervous. Okay. So I went back because I thought I made a mistake, but I didn't. So now what we can do is, to get x, we just divide, right? We just divide by 17. Okay? The 17 is here, but you can't just erase it. You have to divide. So x equals 153 over 17, which is 9. So now we know what x is. Are we done with the problem? Well, you can probably tell from the work here that no, we're not. Right? Because we need y. Well, how can we get y? Well, we know what x is, right? What we can do is take that x and put it back in to either one of these equations. You only have to do one. I put it back in the first one. Okay, I mean, you could have used the second equation, that's fine. When we put x in here, what happens? Well, then x is now gone and we get an equation in one unknown. So we get 2 times 9 plus 3y is 21. And 2 times 9 is 18. We subtract, right? Because now we have an equation with y as our only unknown. So we subtract. So we solve for that. We isolate. Isolate by subtracting. 3y is 3. Divide both sides by 3, right? Right, because we got 3y is 3. So we divide by 3, we get y is 1, and our answer is 9, 1. That ordered pair. That ordered pair. Okay. Now, you might be thinking, some of you might be thinking, well, why did he eliminate y and not x? Well, you could have eliminated x, and I'm actually going to show you that now. So let me just get the recording. So I just wanted to show you that there's more than one thing you can do.